Hello friends, welcome you in this video tutorial, and you are watching KK Java tutorials. In this video tutorial, we are going to talk about the very important class in Java is called StringBuffer. StringBuffer is a basically mutable or modifiable sequence of characters, which is an contrast to a string class, which is an immutable sequence of characters. Thus, in case of a string buffer, length and content of the sequence can be changed through certain method calls, right? These characteristics of a string buffer becomes very handy if you are doing a lot of changes to your string class objects by appending or inserting to that string, right? Since a string buffer in Java is a mutable, a new string object is not created every time when a string is modified, which is turn results in less memory consumptions and not having lots of intermediate string objects for garbage collection, right? So next thing, a string buffer is a thread safe. String buffers are safe for use by multiple threads. If you don't have to bother about thread safety, then you should use a string builder class as it supports all of the same operations, but it is faster as it performs no synchronization. But as I said, a string buffer basically is a mutable object, and that is a thread safe. So if you look into the how this class basically got the thread safety, then you can see a lot of all the methods of a string buffer is synchronized. So if you press Ctrl O, you will list out all the methods available, methods as well as constructor and all the constant you can see after pressing Ctrl O. Then here you can see every method which basically preceded with the clock sign, means this method is synchronized, right? All the methods are synchronized. So that's what the thread safety got a string buffer, right? Now every string buffer has a capacity as long as the length of the character sequence contained in the string buffer does not exceed the capacity. It is not necessary to allocate a new internal buffer array. If the internal buffer overflows, it automatically made larger, right? And how we can create an object of a string buffer, that you can see there are 4 constructors provided. So first constructor basically that creates a string buffer with no characters in it and an internal capacity of 16 characters. Then we talk about the second constructor, which basically takes an argument as capacity, and this basically constructor creates a string buffer with no characters in it and a specified initial capacity. Now we have a third constructor which takes a string as an argument, right? So basically this constructor creates a string buffer initialized to the contents of a specified string. The initial capacity of a string buffer is 16 plus length of the string argument, right? And we have a fourth constructor which takes a char sequence as an argument. So basically this constructor basically creates a string buffer that contains the same character as the specified char sequence. The initial capacity of a string buffer is 16 plus length of the char sequence argument. So this is all about the string buffer constructor. So let's go ahead and try to understand some methods, important methods available in the string buffer. So here I have created a project, a string buffer example, and here I have created a several client programs. So let's start with the first program. Here first of all we'll see what is the length and capacity methods in a string buffer. Since we are talking about the capacity here, so it is very relevant to discuss length and capacity methods of Java string buffer, as it becomes confusing for some people to distinguish between these two methods. So let's try to understand. Here you can see I have created a string buffer using a default constructor, and here I am trying to print the length as well as capacity, right? So when we talk about the capacity, right, so this method basically returns the current capacity. The capacity is the amount of storage available for newly basically inserted characters beyond which an allocation will occur. So we have created a string buffer and try to print without adding any string in this string buffer we are trying to print the capacity. Let's see what capacity is getting printed. And here we have a method is called length, right? So length returns the basically character count. So how many characters is going to hold by this string buffer? Let's run this application and see the output. Now here you can see length is printing 0 and capacity is 16, right? So here whereas when we initialize the string buffer basically so here you can see where length method returns the character count within the string buffer, the capacity method will return the current capacity. So if you create an empty string buffer object, its length will be 0, but capacity will be 16 by default, right? So I hope you understood. Now let's go to the second client program, and here you can see now I have created a string buffer by using the second basically string buffer constructor which accepts a string as an argument. And now let's see what length and capacity is getting printed, right? So if I run this application, cool, at this time length is printed 7 and but capacity is 23. So what is 7? 7 is the count of character which is going to hold by your string buffer, right? So here you can see whereas when you initialize a string buffer with a string example where length of the string is 7, then length method is returning 7, whereas capacity method will return 23, as in that case initial capacity of a string buffer is 16 plus length of the string argument. So 16 plus 7, and that's what you are getting capacity as 23, right? Now let's go ahead in the next example, and here in this example we'll try to understand about the insert and append method of basically a string buffer, right? So when we talk about the insert and append method, the principal operation on the string buffer in Java are the append and insert methods. Most of the times you will use a string buffer class over a string when you are appending or inserting to a string, right? That won't result in creating lots of a string new object with every append as a string buffer object is mutable, right? Append and insert methods are overloaded so as to accept data of any type, like there are overloaded versions which makes basically which takes a primitive data type like int, float, long, double as parameter, apart from having versions which take a string buffer object as parameter, right? Each of these overloaded version effectively converts a given data to a string and then append or insert the characters of that string to the string buffer, right? The append method always adds these characters at the end of the buffer. The insert method adds the character at the specified index, right? So let's try to understand these things through an example, right? So here you can see I have created a string buffer, empty string buffer, and I'm calling append method on it. So initially I have appended one string, then again I'm calling append method and try to append the second string, and similarly calling append method several times. And here you can see in first 3 append method I am passing a string, and third next append method I am passing a number, right? It's an integer. Again I have passed a string, and again I am passing the kind of double data type. And so if you look into the append method, there you will get a lot of overloaded append method which accepts different kind of parameter, and this is kind of method chaining. And finally this will return you the string buffer only. And here what we are doing, we are converting this string buffer, right, into a string by calling the toString, and we are trying to print what basically what data is basically held by the string buffer, right? Now here you can see what we are checking. We are checking SB, that is string buffer, and SB1, which we got by performing a lot of operation on the SB only, that is a string buffer only. And we are checking both SB and SB1 are pointing to the same memory location or not. If that is pointing to the same memory location, that is going to print true, else false. Now again, how we can distinguish a string buffer with a string? So that's what we have created one string object, and here we are performing concat operation on this string, and we are storing into the new reference variable is called str1, and we are checking again str and str1 whether pointing on the same memory location or not. If that is pointing on the same memory location, this will print true as false. Let's see what output we are getting over here. So here is the output, guys. So after append, right, so whatever we have appended in the string buffer, that's getting printed. Here you can see. Now SB and SB1 both are pointing on the same string buffer, right, and that's what you are getting value as true. But in case of a string, both are str and str1 printing on the different memory location. That's what we are printing value as a false, right? So as we know that a string basically you have an immutable object. So whenever you call any method on a string which basically changes internal string which is held by your string, then basically that creates always the new object basically when you call any method on the string, current string, and that's what that is called immutable object. But your string buffer is mutable, and that's what these two objects is pointing on the same object, right? So here you should note that append method is used with a string and primitive data types as a parameters and appended to the string buffer just to check whether the references remains same or changes or new reference SB1, right, of the string buffer is created. It can be seen that SB and SB1 both are pointing to the same string buffer, right? New object is not created for every append operation, right? Same thing is done with the string, right? Here we have done same thing we have done for the string, and data is concatenated to the original string. Here again another reference str1 is created, but str and str1 are not pointing to the same string object because new string object is created with every concatenation as a string is immutable, right? Now let's go to the another client program, and here you can see I have a client program. There I have demonstrated how we can work with the insert operation in the string buffer, right? So here basically here my string buffer contains a word is called late, and we are trying to insert a substring at index 2, right? So if you run it, then this will give you the length as a word, because first character is a zeroth index, then first index, then second index. So after n is getting inserted. So that's the use of basically insert API. So you can call the main insert operation, and that will perform in the same string buffer. So that's what a string buffer is mutable, right? Now if you we have another client program, that is a fifth client program, and there let's see what we have written. Now here one of the very important operation using a string buffer, you can do some kind of a reverse operation, right? One more convenient utility method provided by the string buffer class in Java is reverse method. In a string class there is no such method. In case you want to reverse a string and a string buffer using a string buffer, it's just a method call. So here I have a string string buffer which contains test string. I want to reverse it. So simply we'll have to call the reverse method, and this string will be reversed, right? So just this string is reversed, and we call the toString method, so that this will give you the string equivalent of your reverse basically string, right? So basically a string buffer class also has a lot of methods like substring, index of, last index of method, which provide the same functionality as the string class, right? But one thing you will have to keep in mind, a string buffer is always a mutable object, and that is a thread safe, right? So that's all I have in this video tutorial, guys. I hope you enjoy learning this video. This code I am going to check in on the GitHub, and GitHub location you can get from the video description part. If you really like this video, then hit on the like button, and don't forget to share and subscribe my YouTube channel.